Morning. Today I'm going to show how to use it shows the fx-570 Classwiz calculator to solve the nonlinear equations fx equal to 0 using fixed point iterations method by using two different ways. One is using the calculate menu, another one is using the spreadsheet menu. So first of all, let's revise back what is a fixed point iterations method. If we have a nonlinear equation fx equal to 0, and we can rewrite in the form of x equal to gx, x equal to gx, such that your modulus of g prime x naught less than 1, then by the fixed point iteration method, its iterative formula is given by xi plus 1 equal to gxi. The I start from 0, 1, 2. Meaning with x0 you can find x number 1, with x1 you can find x2 and so on. And the iteration will continue until modulus of xi minus 1 less than epsilon for a given epsilon, and the root of the nonlinear equation is xi. For example, given the graph of y equal to x squared, the parabola, and the y equal to cos x from -2 to 2 here, finds a positive root of x squared equal to cos x. Actually, we would like to find the root of x squared equal to cos x. Let's say we don't have the software to plot it here, then we'll break this nonlinear equation x squared equal to cos x by y equal to x squared and y equal to cos x. So the intersection point of these two nonlinear equations will be the root of the x squared equal to cos x. And we want the positive roots here, mean the root this is a positive root here. Okay, so show you using the calculator. Actually, our calculator menu 1, you can solve the nonlinear equation directly by inputting the nonlinear equations into your scientific calculator. So we're going to input the nonlinear equation x squared equal to cos x, alpha x squared. So we make it minus cos alpha x. Make it become fx equal to 0. So we have the nonlinear equation x squared minus cos x. Okay, and then I'm going to solve this one. So solve is on top of the top button. So shift plus yellow color, you need to press the shift button. Okay, let's say we want to find the positive roots here. So for using the solve button, we need to input one initial condition, one point, initial point. Let's say x equal to 1. Once you put 5, you may take longer iteration. So put x equal to 1. So they give you the roots here directly 0.8241. So this is directly use your calculator to solve the nonlinear equations. And then plot this nonlinear equation. We plot the nonlinear equations. You only get the root but not the graph. Okay. And then here, if you want to see these two graphs, where the nonlinear equations x squared equal to cos x, if I in the calculate menu, I cannot get the graph directly. So you can actually go to menu 9 table. Okay, first of all, I'll show you how to get the x squared equal to cos x, where we break it into two graphs. Where the first function is fx equal to x squared, so alpha x squared. The second function will break it into cos x, so cos and let's say I put the range from -5, starting 5, ending 8, let's say 5, equal step side 1. So they tabulate the fx and gx value. Now to get the graph, you have to scan the QR code, the yellow color, on top of the option button. So you press Shift Options. Use your handphone to scan this QR code. Okay, now you can see. You can get the graph in the table mode, but not in the calculate mode. In the previous lesson, I also shows that if we got the polynomial equation, you can get the graph from the equation mode tools. How about if we just key in x squared minus cos x, we get the graph directly of the graph, the graph of the nonlinear equation x squared equal to cos x. Again, let's say the functions directly now is x squared minus cos. I just want one graph, so I put gx here equal to 0. Then again, you have to scan whether you can plot it. So it means if you want to get any graph, you may go to the table mode, put the range for the graph that you want. So the second function I put is 0, so it's a yellow, blue color. So this is a graph of x squared minus cos x. We would like to find the positive roots here. So between 0 to 2, let's say for fixed point later on, I'm going to input the image starting point x equal to 1. So here I've shown if we break it into two functions, this one is for if you don't have the software but you would like to sketch it manually. So we may break it into y equal to x squared, because we know easily can plot the parabola, and then we can easily plot the cos x. So the nonlinear graph, the root of the nonlinear graph x squared equal to cos x is at the intersection point of these two graphs. If you can use a scientific calculator, you can directly get this one compared to here, but you cannot plot it into calculate menu. You can only plot it into the table menu. Either you break it into two functions, fx is x squared, gx is cos x, or to get the original non-linear graph. And then this now, if we want to turn off gx, actually you can go to shift menu, find the table, and then choose only fx. Now it's only fx. And when you have the trigonometric function, make sure your angle unit in radian, because mine already in radian. So now we come back to our content, how to solve it using fixed point iteration method. We have the nonlinear equation fx equal to x squared minus cos x. So to get a fixed point iteration method, you must make x as a title. So in this case, I will write x equal to cos x equal to square root cos x equal to the square root cos x, and choose x not equal to 1 as a starting point. because it's quite near to the roots. And then, okay, before you start your fixed point iteration method, after you choose x equal to third cos x, so your gx is actually the third cos x. Then you need to find the derivative of your gx, and you get g prime x is the ddx is square root cos x. You have sin x, negative, because the differential clause is negative sin x. And then you have, this is power half, okay? That's why you got half here. And then you differentiate sin. The differential cos is negative sin x, so you square root is half, so you have half. And then this is a cos x power half. So for differentiation, the power half will be half minus 1, is minus. So half minus 1 is negative half. Negative cos x power negative half. That's why you have it divided by square root cos x. So this is the derivative for your gx. After that, you take the modulus of g prime x naught. You substitute x here by 1. We obtain this is 0.5724, which is less than 1. So gx satisfied the convergence criteria. Once we can use the iterative formula xi plus 1 equal to gxi, where our gxi is actually square root cos xi. And then I'm going to show how you can use normal calculate menu, and later on the spreadsheet menu to solve it quickly and easily. Go back to menu 1. So first of all, we have here the initial point x equal to 1. And we have the formula is actually x I plus 1, xi plus 1 equal to third cos xi. Our x naught is 1. So I'm going to key in this formula exactly into your calculator. Alpha x for variable, the red color variable a, b, c, d, e, f, x, y, n. We need to press the alpha button. Then I want the equal to alpha calc, and the square root cos alpha x. So in the calc button, of course we cannot put the I here, so I just key in x equal to square root cos x. So x equal to square root cos x, and then I calculate. So they ask me the starting value of x. I'm going to key in 1. Let's go one more. If you want to fix 4 decimal point, so shift menu, the number formats, and number 1, we have fixed to 4. Because one I equal just now, this one. The first time I input x equal to 1, then I get 0.7351, still a lot at the back, and this value, why I put x equals third cos x, this value is stored in x. And then I go to fix 4 decimal place, and I equal against, the value, this value is stored in x, so it is automatically replaced in here. So I press equal, so 0.7351 is automatically substitute into right hand side, and then you get here 0.8613 here, the second one. So with this one, x equal, you no need to put it the new input. You see, even though I fixed it, but it's actually pick up all the decimal place, but just display purpose, I write down 4 decimal place. So with this method, then you just keep on pressing equal, so 8316, 8208, until there's no more changes for your x. 256, 8235, 8244, 8240. Okay, and this one is actually I calculate the absolute error for x number 1 with x naught. So I notice x9, okay, absolute meaning the error, okay, for I equal to 9 is actually x9, modulus of x9 minus x number 8 is 0.004, which is less than epsilon. Hence, the root will be x number 9, 0.8240. So only, that's it, 8241. So no more changes. We can pick, this is the roots. So using this one, x equal square root cos x, you just need to input, okay, your starting value, then you keep on pressing equal, okay, then until no more changes on the x, so you get that is the root. You can try it without using x equal. You just input the function square root cos xi. So first time you input 1, you get this value. Okay, and then you need to calculate again. You need to put it the new input in order to get 0.8613. Okay, after that, you need to calculate again. In order to get 0.8071, you need to key in 0.8613. So that's a difference. If you don't use x equal, you need to key in the new input in order to get the new output. Okay, however, using this way, you just need to key in one time, first time. You key in 1, okay, then you get the second output, okay, 0.7381. You will get because x equal means, okay, the value, for example, 8241 is stored in x. So when you calculate, when you equal, you automatically in the memory. So you equal one more time so to confirm. So this is the output. Okay, now we would like to show, okay, how to get this output using the spreadsheet menu. This input menu number 8, which is a spreadsheet menu like in the Excel. However, we have only 45 rows and 5 columns. There's a limitation, 45 rows and 5 columns. Okay, and the I here, I no need to input. So the spreadsheet start with rows 1 until 45, columns start with A, B, C, D, E. So you cannot key in X in the spreadsheet menu, but you have to refer to the location of the X is stored. If you recall, let's say for example, this is cell A1. So first of all, cell A1, I input the initial value 1, 2. Now I'm going to input the second cell. Okay. To calculate the x number 1, we will use, okay, square root cos, okay, x naught. Okay, where the x naught is stored in A1. So we have to do alpha equal A1 square root cos, okay, x is stored in A1, so alpha A1. Okay, this is close the cos, to close the square root, one more. Cos in the spreadsheet menu, it is not natural display, so make sure, okay, you close correct. Okay, the parenthesis correspondingly. And you equal, so you get in 7351. Because this one shows formula. Okay, later, okay, you want to show value, later I'll show you how to show the value in the cells. Because in the spreadsheet, they got limited space. They can show it. This one show 3 decimal place. If you want to show more, you can actually shift to find the spreadsheet number 2, and then you want value number 2 again. So you click 4 because previously I fixed to 4 decimal place. If you want more, then you go again, shift menu, find the fix. Then you choose how many decimal places that you want to see. Okay, now, if using spreadsheet menu, I need to copy and then paste. Just how we input in the calculate menu, we input x equal square root cos xi. You input 1 and then you keep on pressing equal. But in spreadsheet menu, I need to copy the formula. So I go back to this one first to show the formula. Number 2. I want the formula number 1. Then I want to copy options. I want to copy formula in A2, which is I key in the square root cos A1. A1 is my x naught. So I options. Copy is number 2. And then we want to paste it down the formula. Paste it until no more changes on your the next x with the previous x. So we go down, paste, we go down, paste, go down, paste, 2, 5, 6. We keep on pasting until no more changes. 2, 4, 4. So you see, take 2, 4, so we press it. Take 2, 4, 1. So take 2, 4, 1. You can see 11 and 12 is actually iteration 10. And 11 and 10, no more changes. So if you want, because you just keep on press the tracer, paste the formula. Okay, once done, you may just shift it AC first click to clear the place here, AC. So, okay, this is a relative flow in Excel. The formula just now we key in is actually square root cos A naught. So, in the cell A1, so once you paste it will automatically relative to the previous case. So, in this one, it will come in when I key it into here, pick up the previous row. So when I copy paste down, in this cell will take up this one. This one we input 1, and then we key in formula square root cos A1 and copy and paste, so it becomes automatically in cell A2 we depend on cell A1, so cell A3 will depend on cell A2. Cell A4 depend on cell A3. The formula automatically relative to groups. And then to see the value, shift menu, the spreadsheets, show the cell, we want value number 2. So we have have shown how to solve the nonlinear equation. This is fx equal to x squared minus cos x using fixed point iteration. Where I will write the fixed point iteration formula xi plus 1 equal to square root cos xi. So I have shown using two methods. One is using the calculate menu. In the calculate menu, if you use the calculate menu, you in alpha x. If alpha x equal, the equal is using the red color equal actually. In the calculate menu, x equal, the equal is alpha the red color. X equals square root cos xi. And you're asking what's the value of x, you key in 1 equal, you get 0.7351. Next, you just keep on pressing equal until no more changes on your x. So that is the root. And the root is actually the last value. Okay, if using spreadsheet menu, the same thing, I'll just key in the cell, the first cell as my initial point, x equal to 1. And then the difference is, I did key in this one. Okay. I just key in this part, this formula. But x here, okay, I just key in, okay, the square root, okay, cos the x naught is actually stored in cell A1. is my formula, shift menu, number 4, number 2, I just key in this formula. The equal again in spreadsheet menu, you need to alpha count to get the red color equal, not this equal. This is for normal calculation. To assign a formula, we use the red color equal. So equal square root cost. X note is stored in cell A1, so you put A1. Later on, you just copy. To copy is actually option. Go down, copy. And then to paste the formula, you go to the cell where you want to paste, you press it. So for this fixed point iteration, so you keep on go down, press equal, go down, press equal until normal changes. That will be your roots. And you can also use the table menu. Table menu. This one is plotting. It breaks a nonlinear equation. This is being written. We just key in directly the nonlinear equation x squared minus cos x. Okay, and this one defaults the table menu. We have two. Okay, can key in two functions compared to the previous model. You can only key in one function. So okay, gx you can let it equal to 0, or you can go to the setting there to turn off this gx menu. Okay, or just now previously in the questions, they break the nonlinear equation x squared minus cos x into two functions because maybe if you don't have the software or calculator to plot it, how to plot it manually. So mean we'll let this one x squared equal cos x. So you plot the graph of x squared and cos x. The root is actually the intersection point. And the question 1, the positive root, that's where you put the starting point x equal to 0. Okay. So in this case, thank you for attention for fixed point iterative method for solving non-linear equations. Thank you.